Okay, starting with section 6.5, you can see our learning target is I can factor polynomials. Factoring is really undistributing. It's undistributing and reverse distributing if you'd like. If distributing is technically multiplying, undistributing or factoring is dividing. It's undoing that. So imagine that we have number 1 here. The very first thing you should always look for when you're going to start to factor is to ask yourself, can I pull out a greatest common factor? Is there some term in common with everything? And look at that. You've got x to the third minus 5x squared. You've got a plus 6x. There is something in common with all of them. What do you think it is? An x, right? All of them have at least one x. By the way, look for the smallest power of your variable. That's what will be in common. So I'm going to reverse distribute, so to speak. I'm going to pull out an x. What I'm really doing is I'm taking away an x from each one of these. Technically, I'm dividing it out. But if I take one x away from x cubed, what am I left with? X squared. If I took one x away from the 5x squared or minus 5x squared, I'd have a minus 5x. If I took one x away from the 6x, I'd have a 6. If you're ever wondering, hey, did I do this right? You could double check by quickly redistributing, remultiplying it back in to double check that it works out. Now, guys, I wish I could tell you we're done, but we're not. If you look inside, you're going to see that we have a trinomial. And when your coefficient of x squared is a 1, we've been talking about this over the last couple of days. And this is why I started reviewing with you the last 2 days. A quick shortcut in terms of factoring will be, it becomes a puzzle. You're going to say, could I find two numbers that when they're added together, you'll get negative 5. But those two numbers will also multiply to a 6. So what we said yesterday is begin to check the multiplication. How can you multiply to a 6? What two whole numbers could get multiplied together? 2 and 3, and 1 and 6, I'm hearing. Very good. Or 6 and 1. Regardless, those are your only two possibilities. Now, of course, you have to not only multiply to the 6, you have to add to the negative 5. So a negative is coming into play here. But please remember that we're multiplying to something positive. So what do you think we could find here to make this work? What two numbers would do it, do you think? 2 and 3. But if they're both positive, they wouldn't add to negative 5, right? Make them both negative. Very good. Very good. You'd want negative 2 and negative 3 in there. And guys, that's your check. You can say, hey, negative 2 plus negative 3 is negative 5. But just as important, negative 2 times negative 3 is positive 6. You have to check both criteria. Okay? And sometimes kids will ask, hey, is it okay if I switch the x minus 3 and the x minus 2? Technically, you could do that. The order of these really won't matter. But we are done factoring. Let's take a look at number 2 real quickly. When we're looking at problem number 2, the big question is, what is in common that I could divide out from a 16x to the 4th and a minus 2x? A 2 would divide into both, and what else? An x. And 16 divided by 2 is 8. You see, we are undistributing. We are dividing, right? Distributing is multiplying. Factoring out means divide. I had 4 x's in a row. That's like x times x times x times x. But I just took one of them away. I'll have x to the 3rd. Ooh, what's left here when I factor that out? a 1. You see, 2 divided by 2 is just a 1, and I've taken that x away. You could recheck, you could redistribute and see what's going on. Now, guys, when you have a cubic, like 8x cubed minus 1, if we ever saw that, we're going to be done, actually. There is, in fact, a cubic formula that you can learn in some other classes. We're not even going to bother with it. We're going to keep it nice and simple. But if we see a quadratic with trinomials like we've seen in the past, like number 1, we'll have to keep breaking it down. Okay, guys, we're going to get moving here. We're going to skip number 3 for the sake of time. We have a short day here. We're actually going to skip number 4. And the last problems that we're going to do today are going to factor using grouping. Now, I'm going to show you what the grouping is always going to be about. The final stage, if we look at number 5, the final stage of grouping is always going to wind up with 2 parentheses that are exactly the same. They must be identical. If your parentheses are not the same, you're not going to be able to be doing the problem right. Something went wrong, in other words. So every time you're going to get a grouping problem, the 2 parentheses will be the same. Now, just to help you out, I want to show you something. What if the y minus 2 in green here was represented by the letter W? I just want to show you that. Because think about it. You could say, ooh, that y minus 2 looks kind of bulky, and let's just represent it with a very simple letter, just one variable. Now, if I gave you xw minus aw, would there be a common factor that we could pull out? What do you think we could pull out? A w. And when I'd undistribute the w, what would be left? X minus a. Guys, that's what's going to happen right here. This is your w. We're going to pull that out in front. We always pull our parenthesis out in front. And then what's left? We're going to have a new set of parentheses. We'll say x plus a. You can see that's really what we're seeing up here as well. This is the final stage of factoring by grouping. You'll have 2 parentheses. That's what you could factor out from both. And then you'll just have an x plus a left. Well, we're going to do 3 more problems, and then we'll do a calculator problem real quickly. But I do want to point out for number 6 and number 7 and number 8, they are in fact more involved. What you're going to have to do is break this up into 2 separate groupings. In general, guys, what you will see is you're going to get 4 terms added or subtracted together. 4 terms added or subtracted together. Look at just the first 2. Just start there and ask yourself, is there a common factor, the greatest common factor I can pull out from x to the 3rd minus 2x squared? What do you think? X squared. Take your smallest power of x. When I take that out, when I divide it out, what's left? X minus 2. Now we're going to do the same exact thing to the minus 16x plus 32. Please hear this, though. This is so critical. When the second grouping starts with a minus, you must divide out a negative. You're going to factor out a minus. So I'm looking for the greatest common factor, the biggest common factor, that would divide into negative 16x and also 32. 16, a negative 16. I heard someone say 8. 8 does work, but we're looking for the greatest common factor. So when you see a lead factor of 16 here, say, hey, could 16 maybe divide out? Now, if I'm dividing by a negative 16, this would be left with an x. What's 32 divided by negative 16? Minus 2. See, you're taking a positive 32, you're dividing it by negative 16. But this is maybe the most important thing I want you to remember. Please remember, those parentheses will always, always, always be the same. If you've done this right, you're going to see what I've highlighted in green, x minus 2 showing up twice. And remember, that's kind of like what we were calling our W. That's our greatest common factor now. I can pull those common parentheses out in front. And then what's left inside? What do you think? X squared minus 16. Now, guys, here's what makes factoring a little bit trickier. You always have to say, can I keep going? Look at that x squared minus 16. It actually can break down more. Does anybody remember what that would factor into? X plus a 4 and x minus 4. You might remember the a squared minus b squared, that factored into a plus b, a minus b. That's what you have to do to finish that problem there. Okay? So, lots going on. Let's take a look at number 7. Guys, as we look at number 7, let's take a peek right here at the first two terms and the last two terms. What could I divide out from a 4y to the third and a minus 5y squared? What do you think I can pull out? Y squared. And what's left then? 4y minus a 5. Now my focus is just on this 8y minus 10. It's a plus 8y, so I don't pull out a negative. I'm going to pull out a plus. But what's the biggest number that I could divide out? A 2. 2 is the biggest number that divides into 8 and negative 10. When I divide both the 8 and the negative 10 by 2, what am I left with? 4y minus 5. Hey, did we do this right? Yeah. That's something to be very happy about. You've got the same parenthesis. You could say, this is great. I know when I've done that, I'm right. I'm going to pull that common green parenthesis out in front. And then what am I left with? Y squared plus 2. Y squared plus 2 cannot break down. It's only when you have a difference of squares that you could keep going. Okay, so thank goodness that's pretty much where we stop. Here, you know what? We'll make this our last one of the day here. Number 8. Guys, as we look at number 8, same thing. Factoring by grouping, guys. We're going to say, look at the first two. Look at the last two. And again, our goal is to divide out the biggest thing possible. What can I take away from the x cubed minus 4x squared? X squared, and what are we left with? X minus 4. Do you know what some kids quickly catch on to? They're going to say, if I'm going to do this right, the other parenthesis has to be an x minus 4. Do you see what I'm saying? You can write that first, because you know it must work that way. But the bigger question is, what can I divide out of negative 25x plus and 100? Negative 25. If you were to check by redistributing, you'd see it works out. But here we go again. Really good news. You can see the same parentheses. Let's pull that out in front. What's left? X squared minus 25. And then what? What's the x squared minus 25 going to break down to? X minus 5 and x plus 5. And guys, we are done.